Okay, guys, I'm going to start the 5152 quiz review wrap up with the verifying stuff, and then I'll come back to the first page of simplifying in a second. But again, if you look at what we posted on Canvas in the modules, I posted worked out solutions. There's a bunch of alternative solutions because there's a lot of different ways you can look at these problems. So just because I do it one way doesn't mean that's the only way you can do it. It just has to make sure that it logically makes sense. So please try to practice these on your own. When I first look at this one on 15, I see that I have 1 plus cotangent squared, which I'm going to think is an identity because it's a trig function squared and it's attached to a plus or minus 1. So I'm going to keep sine squared just like it is, and I look at my trig identity sheet and I see that 1 plus cotangent is the same as cosecant. So that makes things a lot easier now because we got rid of this plus sign, or now just down to multiplication. So now I'm going to keep my sign just like it is, sine squared over 1, and I know that cosecant is the same as 1 over sine squared. And if you notice now, guys, the sine squareds will cancel out, and you have 1 equals 1, which is what we were trying to get to. So now we look at 16. Okay, these are getting a little more difficult to look at and such. So again, you can start on whichever side you want to, and we have alternate solutions with what I posted, so you guys can look at that. But when you look at 16, I think that the left-hand side looks a little harder than the right-hand side. That's just me, but so that's what we're going to work on. So I'm going to leave tangent squared, sine squared alone. And I'm going to say, okay, tangent squared, I'm going to change that into sine squared theta over cosine squared theta minus sine squared theta over 1. So we have two fractions that we're adding or subtracting, so we need to get a common denominator. My common denominator would be cosine squared theta. My first fraction has the cosine squared, so we'll leave it. My second fraction needs the cosine squared on the bottom, so we're going to multiply the top, because what you do to the bottom, you do to the top. So I have minus sine squared theta, cosine squared theta. Now from here, you can go a lot of different ways, but I noticed that the numerator, this term and this term both has a sine squared. So I'm going to factor out the sine squared theta, and then sine divided by sine is going to move 1, and then I have minus cosine squared theta over cosine squared theta. So I look here and I say, okay, well, wait a second. 1 minus cosine, that's a trig identity. That's sine squared theta. So again, at this point, you can look at this a little differently. You can look and say, okay, I'm trying to get to tangent squared, sine squared. If I think of this algebraically, I can break this up into sine squared theta over cosine squared theta times sine squared theta over 1. And when I do that, sine over cosine is going to give me tangent squared theta times sine squared theta, which is what we were trying to get to over here. Again, there's different ways to do it, so look on Canvas on the under modules where I posted the answers. You could see the alternative solutions that we used. So I look at 17 and I say, okay, obviously, guys, the left-hand side looks a little more difficult than the right. A couple different ways you can go with this. I'm going to say, okay, I don't have anything squared attached to a plus or minus 1. I do have different denominators, but I'm going to go ahead and change denominators. I'm sorry, not change denominators. I'm going to change everything to sine and cosine. Make my life a little easier. So secant, same as 1 over cosine divided by cosine. Good. Minus tangent is going to be sine over cosine divided by cotangent is cosine over sine. So all I'm going to do is I have two fractions that I'm dividing and subtracting. I'm just going to rewrite it left to right horizontally. So I have 1 over cosine theta times, flip is good because this is over 1, so 1 over cosine theta minus, I have sine theta over cosine theta times, when I flip it, becomes sine theta over cosine theta. So if I multiply these two together, on the left-hand side, I have 1 over cosine squared theta. On the right-hand side, I have sine squared over cosine squared theta. If I write this over one denominator, my denominator is the same as cosine squared theta, so I have 1 minus sine squared theta. And you guys should recognize that 1 minus sine squared is the same as cosine. So cosine squared theta divided by cosine squared theta equals 1, which is what we were trying to get to over here from the very beginning. And again, like I said, for 16, 17, 18, there's a variety of ways to do these problems, so make sure you look through the alternate solutions that we posted on Canvas. But as long as it mathematically, logically makes sense, you guys can get credit for stuff. You just can't create your own new math. So look here at this problem, and this problem's got a lot going on. A lot going on. You can do a couple things. You can FOIL, you can get common denominators, you can break everything down, whatever you'd like to do. I'm going to go ahead and break down into sine and cosines, just because I see there's nothing that is squared attached to a plus or minus. I don't have any denominator to get rid of, so I'm just going to go ahead and say, all right, let's go to our basic trig functions, sine and cosine. I'm going to change tangent is to sine theta over cosine, plus cotangent would be cosine theta over sine theta. So I'm going to leave my sine and cosine, just leave it alone, we'll deal with that in a second. But if I look here, I'm going to need a common denominator. Well, guys, a common denominator between two fractions, we're just going to multiply them together. So I have cosine times sine, and now we're going to figure out what fraction has and what it needs. The first fraction has a cosine, it needs a sine. Second fraction has a sine, it needs a cosine. So I'm going to have, now I've created something up here, sine squared plus cosine squared. Guys, what does sine squared plus cosine squared equal? Look at your trig identities, it equals 1. So here we have sine theta plus cosine theta times 1 over cosine theta sine theta. So now I have two fractions that I'm just multiplying together. So if I multiply them together, I can say, all right, sine plus cosine times 1 is just going to give me sine theta plus cosine theta over, my denominator is cosine theta sine theta. And then I say, okay, well, now what do? I have a denominator that is not being added or subtracted together. That means I can take each term in the numerator and I can separate it over the common denominator. So I have sine theta over cosine theta sine theta plus cosine theta over cosine theta sine theta. I can do this because my numerator is being added. So now I look and I say, oh, wait a second. Here, the sines will cancel out, so I'm left with 1. Here, the cosines will cancel out, I'm left with 1. I have 1 over cosine theta plus 1 over sine theta. So now let's look and see where we're trying to go. We're trying to get to secant plus cosecant. You guys notice 1 over cosine is the same as secant theta. 1 over sine is the same as cosecant theta, and that is exactly where we were trying to go. On the alternate solutions, we did one where we actually, at this point right here, FOILed and then got common denominators and all that stuff. And that's, you can do that. That's totally fine as long as it makes sense. All right, now we're going to go back to the beginning. We're going to go to 13, and then I'll go up to the simplifying. You start off with something like number 13. All right. Again, obviously the left-hand side looks a little more difficult. Since there's nothing being added or subtracted, there's nothing squared, there's no denominators, this one's super duper easy because we can just go to sines and cosines and see what we can cancel out. Here I'm going to have sine x over cosine x. That's going to be our tangent. My cosecant is 1 over sine x. And then my cosine would be cosine x over 1. And if you guys notice, since we're multiplying, if you want to combine them all together so you can see it, that's fine. Or if you want to just cross out like you can. But if I multiply the whole top together, I have sine x times 1 times cosine x. My bottom would be cosine x times sine x. And if you notice here, sine cancels, cosine cancels, and you have 1, which is what we were trying to prove. All right, and then let's look at 14, and then we'll go up to the verifying. To simplifying, I keep saying that. Okay, so the left side to me looks a little more difficult. I don't see anything I don't have anything squared attached to a plus or minus. We don't have any denominators or anything, so I'm just going to go ahead and FOIL. We're already in sine and cosine, so let's just FOIL. Sine times sine is going to give me sine squared. Sine times positive cosine is plus sine theta cosine theta. Negative cosine and sine is minus sine theta cosine theta. You could write it the other way, it doesn't matter. And then negative cosine and positive cosine is minus cosine squared theta. So if you notice here in the middle, guys, your sine and cosine multiplied together cancels out. So you're left with sine squared minus cosine squared. If that was a plus, those two would cancel out and equal 1. So now I look and I'm going to use this right-hand side as a guide of where I'm trying to go. So I see that my right-hand side has a cosine squared, but there's nothing else in terms of a trig function. So I'm going to look at my Pythagorean identities. I'm going to say, well, is there a way that I can rewrite sine squared? And I can. I can manipulate that formula, and I can rewrite sine squared as 1 minus cosine. And when I do that, guys, it just becomes an algebra problem. I have 1. I have a negative cosine there and a negative cosine there, so it gives me minus 2 cosine squared theta, which is what we were trying to prove. Like I said, all of these verifying ones, guys, there is a million different ways to get to the right answer. As long as you show your work and you show your thought process and it all makes sense, you're good to go. You'll get credit for it. All right, for simplifying, all you're doing is just trying to make smaller, trying to make more condensed. I look and I say, okay, I don't have anything squared, no plus or minus attached to it, no denominator. So I'm just going to go to sines and cosines. So I'm going to change this tangent to sine over cosine times cosine over 1. My cosines cancel, and my simplified trig function right here is just sine theta. All right, let's go over here to number 2. I see 1 minus cosine squared in my numerator. So I look at my trig identities, and I say, wait a second. 1 minus cosine squared, well, that is the same as sine squared. So I can replace 1 minus cosine with sine squared. Then I look at my trig identity sheet, and I say, well, sine squared over cosine squared can simplify to tangent squared theta. Okay, number 3, again, nothing being added, subtracted, no trig function squared attached to plus or minus 1, so we're just going to go ahead and simplify. Go to sines and cosines. Cosine is going to stay as cosine over 1. Cosecant is the same as 1 over sine. If I multiply these two together, I get cosine theta over sine theta, which if I look at my identity sheet, that's a reciprocal function, or that's a quotient identity function. Cosine over sine is cotangent. Okay, again, number 4, there's nothing being added, subtracted. We don't have anything squared, so let's just go ahead and break down to sines and cosines and simplify. So I have sine theta over 1 in my numerator. Secant is the same as 1 over cosine theta. And then tangent, I'm going to rewrite as sine theta over cosine theta. So when I simplify this, I'm going to multiply the top. Sine theta over cosine theta divided by sine theta over cosine theta. Again, you could have left that as tangent if you wanted to and gone the other way, but if we keep change flip, we have sine theta over cosine theta times cosine over sine. Those will cancel, and you just have 1. And number 5, pretty much the same thing. I'm going to rewrite cosecant as 1 over sine theta. My cotangent, I'm going to rewrite it as cosine theta over sine theta. If we keep change flip, we have 1 over sine times sine over cosine. My sines cancel, so I have 1 over cosine theta, which that's a reciprocal identity. 1 over cosine is the same as secant theta. All right, number 6. I see a 1 minus attached to a trig function squared. So I look at my identity sheet and I see that 1 minus cosine squared is the same as sine squared. So I'm going to replace this with sine squared theta. So over here I have sine squared theta over 1 divided by tangent is sine squared over cosine squared. If we keep change flip, I have sine squared theta over 1 times cosine squared theta over sine squared theta. Those cancel, and I'm left with cosine squared theta. All right, guys, for number 7, same thing. We're just still simplifying. There's nothing added, subtracted, nothing squared. So I'm going to say in my numerator, cosine theta over 1. I'm going to change secant to 1 over cosine theta. In my denominator, my tangent, I'm going to rewrite as sine over cosine. And I notice here that these two will cancel, so I'm left with 1 over sine theta over cosine theta. At this point, you might recognize, oh, it's cotangent. But if you don't, no worries. Just say 1 times, I'm going to flip this to cosine over sine. And that's where we get our cotangent theta. All right, sine over cosecant. Sine over 1 divided by 1 over sine. If I keep change flip, I have sine over 1 times sine over 1, which when we multiply those two together, I get sine squared theta, and that is simplified. Yes, sine squared theta does equal 1 minus cosine squared, but when we simplify, we want to make it as small as possible, so that's how we're going to leave it there. All right, if I look at number 9, again, there's a bunch of different ways you can do this. I personally see a monomial denominator and a plus sign in my numerator. That means I can think algebraically and rewrite this as tangent theta over tangent theta plus cotangent theta over tangent theta. So when I do that, I look at that and I say, oh, wait a second. Tangent theta over tangent theta equals 1 plus, I can rewrite cotangent as 1 over tangent theta over tangent theta. You could go to sines and cosines here if you wanted to. I'm just doing something a little different. So I have 1 plus, if I keep change flip, I have 1 over tangent theta times 1 over tangent theta. That gives me 1 plus 1 over tangent squared theta. Well, 1 over tangent squared is the same as cotangent. So I have 1 plus cotangent squared. Look and see if that's an identity. You could simplify that a little more. Is there a Pythagorean identity that has 1 plus cotangent squared? And there is. It's cosecant squared. You could have done the exact same thing with that problem, guys, and changed everything to sines and cosines and gotten the same answer. All right, a couple different ways you can look at this here, guys. I saw this cosine squared, and I was like, oh, cosine squared, that's the same as 1 minus sine squared theta, all right? So now I look and I say, oh, that's the difference of perfect squares. That's 1 plus sine times 1 minus sine. And when I do that, I look and I say, oh, I have a 1 minus sine on top, 1 minus sine on the bottom, so that just simplifies to 1 plus sine theta. All right. Again, a couple different ways you can look at this one. I'm just going to do it the way that I saw it. I see that I have a monomial denominator and a plus or a minus in the numerator. So I'm going to split this up. I'm going to say secant squared theta over secant squared theta minus 1 over secant squared theta. You can do that when you have a plus or minus in the numerator. So secant squared theta is going to give me 1, and I can rewrite 1 over secant squared as cosine squared theta, and I know that this is now a Pythagorean identity, which is sine squared theta. That was your simplified. And then this last one over here, I forgot to put the theta sign here, so I'm sorry. But guys, I told you always think algebraically. If this said x squared minus 2x plus 1, you would factor it no problem. You would say -1 and -1, and x in the front of my parentheses. But it's not, now it's just a trig function. So this would be sine theta in front of each, sine theta. What we're going to, this would be your simplified. what we're going to in the next sections is you're going to solve and factor and all this, but then you're going to solve. You're going to set it equal to 0 and then solve. But that's next. That's next. So
Sorry.
if you guys could, please look over this. Remember, there's a million different ways to get to the same answer, and you guys you're going to have to think. If you get stuck on something, think. Always try to get to the next step.